All right, so hey everyone, my name is Sander. I work with Textile Photos. We originally started because we wanted to build a real useful application on top of IPFS. And we figured that mobile was the place to do it because it didn't seem like a lot of people were attacking that space. And slowly over time, we've kind of grown, or our vision or mission has sort of grown more into wanting to provide a more like a distributed database and application platform, kind of like we like to think of it as a decentralized iCloud. So let me, so I can share my screen here. I'm not familiar with Zoom, so bear with me.
There's a green thing at the bottom of the Zoom window that says share, like with that arrow pointing up.
Okay.
Looks like you got it. Excellent.
Okay, so what is Textile? And this is sort of a modified version of our README. So it's really texty. So again, we like to think of Textile as providing encrypted, recoverable, schema-based, and cross-application data storage built on IPFS and libp2p. Again, we think of it as like a decentralized iCloud in the future. That's kind of our mission. Decentralized and open iCloud that developers and users can build upon. So what we want to enable people to do with Textile, and I'm talking about users, is to via applications and services securely store your photos, videos, documents, or any other type of file, chat with friends and family, and access your data from anywhere, wherever you are. So these are kind of the core. If you look at the core values of iCloud, we're sort of trying to match those. So iCloud, you know, it's a great place for your photos, your files. It's accessible wherever you are. It's safe. It's up to date. You can take your files with you. You can put any type of file in there. You can collaborate with others, and if you think about it, it's like, you know, your messages. If you're an Apple user, if you have Apple devices, your messages are part of iCloud. The applications that you use are all part of iCloud. Obviously, your data. So when we thought about this, we originally tackled photos because photos are just a really easy type of data to think about in terms of like user ownership. So everyone understands what you can do with photos. People understand, you know, there's different types of privacy around your photos. You don't want your entire camera roll to be open to the public, but you might, you know, want to share with specific groups. And so I'll skip some of this stuff. We are trying to enable people to build other apps like Textile Photos. So we have a mobile SDK that you can plug in for iOS and Android. And we're trying to build it as something that just for the average application developer, someone that might not really be sold on decentralization necessarily, but that they can dive into and actually find that it makes their life easier. So like they could maybe skip user management. They have you know, like data storage taken care of, messaging. So something like a Firebase or a Realm, for those of you who are familiar with that kind of stuff. So how does it work? So at the core of Textile is what we think of as an account wallet. So it's an HD wallet. It's kind of inspired by Stellar's wallet. It's backed by a mnemonic phrase. So you can generate all these, any number of deterministic accounts in this wallet, and then you would use each one of those to initialize a Textile node. And that's how your data is synced between your different devices at a high level. So the main sort of most important data structure is this concept of a operation-based CRDT that we call a thread. So there's different types of updates that go into the threads. There's peers joining, leaving, data being added, comments, messages, and it's really just a Git like hash tree where each, if there's a case where a merge needs to happen, which is almost all the time, because if you're in the mobile world, you're always going on and offline, so you get out of sync really fast. So you end up having this really wide hash tree. But this is our first stab at this, and it's really not terribly complicated. It's just there's a deterministic merge rule that happens. It basically just takes the earlier date and creates another block in the thread that can be recreated on other peers. So like if they have the same two parents, we know that they will always result in the same exact block hash. So all these little updates, we call them blocks, are stored on IPFS, and because they're hash linked together, you can traverse back and recover a thread. Or if you're joining a thread of someone else's thread, you can traverse back and get all the older history. And let's see here. So this is an example here. I know this looks terrible. It's blown up like this. Let's see if I can. Oh, I should have done that earlier. Okay, so here is an example, hypothetical user's account wallet. So they've got these different accounts. And let's say that in their first account, they have these certain threads. So we actually track your different devices, and these could be other apps with a thread. So it only tracks joins and leaves of those peers. And then this might be like someone's camera roll, and it's a private thread that all the peers from that account have joined, let's say, and they've started adding files. And they might have like some videos or like a chat thread. So again, thinking of like the iCloud analogy, you've got your photos, your different chat threads. And let's see, so one of the other large components of this system is what we call cafe nodes. So because obviously we want to do everything we can peer-to-peer, but because of the need for in the mobile world, you want to really handle offline robustly. So you run into that all the time. So what we do is we put the same Textile nodes up into the cloud. We run them on Amazon, and they provide offline inboxing services to other peers. So if I send you a message and you're offline, I will know either from a previous thread that I've been with you, or from your IPNS user profile, I'll know where your inboxes are, so I can send to your various cafe inboxes, and then when you come back online, you download those messages. So looking at I know I'm kind of rambling fast through this, so just feel free to interrupt me at any point. So looking at the internal components here, so obviously we run an IPFS node. If it's in the mobile use case, it's just a client node. So it's only there to be able to traverse the network. And we have two P2P services. There's the thread service, that's the CRDT service that orchestrates state between peers. And then we have this cafe service that you can register with different nodes, and you'll open a user session, which is a JWT session. And anytime you add data to the network, you'll actually pin it on those cafes. And then there's the offline inboxing service I mentioned earlier. And so locally, you want to be able to like list the files or photos that you've added to IPFS. And that's what this files API is for. There's a similar one for just plain messages. So for listing the different messages and threads. And then other components is the wallet, file schemas, I'll get into in a second, and then this concept of file mills that's related to schemas. So one of the core pieces of what we're doing is trying to make, as part of this decentralized iCloud mission, is trying to make a way for people to easily add structured data to IPFS. So we've come up with this system called, it's similar to Transloadit that I've used in past lives, and which is a really nice service for if you want to, in your application, you need to define how like it ingests files or videos. So I want to take this image and I want to create these multiple different sizes and thumbnails. I want to maybe extract some EXIF data, that kind of thing. So in Textile Photos, we actually use a file schema that looks like this. So this translates directly into a DAG node, and you can define what pieces you want encrypted. And each one of these links, not surprisingly, becomes a DAG node link. So this setup here says essentially, let's take the raw image data. Well, in this case, it doesn't care if it's an image. So just take the raw data. We want to save the original. And we're going to send it to, Transloadit calls these robots, like encoding robots, and we call them mills because we're textile. So you send the raw data to the blob mill, and it just encrypts it and stores it in IPFS. And then it takes the output from that mill and it extracts the EXIF data here. Then it'll take that simultaneously, it'll take the output from the raw and it'll create these different sizes here using this image resize endpoint. So there's this is available on the mobile client. In the mobile world, this is running on the node in the phone. It's not hitting like a remote endpoint, but you could imagine if you wanted to make a service out of it, you could run it on a server and do something similar. Let's see. So what that results in is, this is kind of small, but a DAG structure that looks like this. So we've got, so we only added one file here. So we've just got one index and we've got all these different links. And then each link results in a determined D for data link and this /F here, which means it's going to show like the index of the data. So I can show you actually that. Oh, maybe not. So the reason we do the index of the file is because it's the encryption is not ideally deterministic. You don't want to keep adding the same file over and over. So each node locally will keep track of the all the files that are in its node, and you can look up the pre-hash of a file based on its file index. And you can use that in combination with the options that were used to create that file to determine if it's already in the system. So you're not continually adding the same files. So we're getting close to having a usable version that you could build on top of. The main pieces were finishing off the mechanisms for account recovery. So we're doing all the backup to your cafes, but we're missing the piece where you ask the network for your all your thread backups. So that's the tip of all your threads. So it would just be like, give me all my, in the iCloud world, it's really easy because you just ask Apple, hey, I'm proving that I am who I am. We do that. They do that with the Apple ID. We're doing that with your mnemonic. So you say to the network, this is who I am. I need like who's got my stuff, basically. So we're doing that with mostly with PubSub, so dedicated channels on all the cafes that we ask for specific people, users, backups. And so just a note about Filecoin. We don't love we always, I think we see like a need to have these cafes, these federated nodes in a system like this. But in terms of being the place where everything's pinned, we'd like to swap that out for Filecoin. So hopefully we would run like a Filecoin node in a Textile cafe. Here's some stuff about, I won't go through that. I guess I could show some other types of schemas. So you can use JSON schemas here. So if your application needs to, this one's kind of interesting, like if you want to ingest log data, for example, you could define a JSON scheme that looks like this. So it's got, this is I forgot the name of the spec, but some log spec requires these fields. And all this would be being added to a thread. And then over here, this is probably really small, but you can, I guess the simplest use case of a thread is just like a chat. So we have the Textile command line client has a chat subcommand, so you can just invite people to a thread and just start chatting, So what's going on here is each message is being backed up to their respective cafes. And because I'm local, they're just talking directly to each other, but if I was to take one offline, they would communicate via the inboxing setup. So yeah, I think that's a pretty good overview. I know that was probably kind of rambly, but I don't do
that
it.
was awesome. Thank you very much, Sander. We're actually going to get into the Q&A part. So if you have a question, if you can just put it in the chat, that would be excellent. Our first question is from Hannah. Hannah, are you around?
Yeah, hi, sorry.
Hi.
I was curious about the way you keep things private. I heard the word encryption. Does that mean you're encrypting the blocks at rest effectively, or?
Yeah, exactly. So each message in a thread is encrypted with the threads key, the threads public key. So these are, each message is actually a protocol buffer. So if it's pointing to like a DAG node or something, it just, you know, has a hash of that in it. So they're all really, really tiny. But yeah, they would be encrypted by the threads key. So if I invite you to a thread, there's a couple ways to do that. I can take the thread key and I can encrypt it with your public key, or I can encrypt it with a one-time just AES key and put that on IPFS and then send you a link to that. And then if I somehow give you that key, then you could download it. That's for like, if you're trying to get a new user in, that's a good way to do it, because you can just text that URL. But that, doing that kind of, it's like permanently public in a way. So there are different thread types that we haven't fully fleshed out. There is right now, the ones that are fleshed out are an open thread, which just means anyone can create invites to anyone else. And then a private thread, which doesn't accept invites, and that would be like for your account or device peers. We use an internal private thread for that. But
Okay.
we're going to, yeah.
Oh, I'm sorry. I hate to interrupt. If you don't mind, we're actually going to move on to the next question, if that's okay.
Yeah, of course.
Matt, please.
Yeah, I have two questions. One is, do you use any of the built-in files APIs like MFS for IPFS, or did you build all that? Are you directly manipulating the tag and you built your own files related API? And then totally unrelated, are you familiar with IIIF, the International Image Interoperability Framework, and their APIs for images and manipulating images? Did you consider using that? Did you use that as a reference point when thinking about schemas and things?
So the first one, we don't use that. We just, you know, the actual data is still broken up into the blocks and all of that. So it's kind of, I guess, more of a higher level concept of a file. And, you know, a file, it could be a JSON object or whatever. But yeah, it's when you, if I was to create like a photos schema and then create a thread with that, it does do the validation. So like if I send you a DAG node that is supposed to be added into that thread, my node might reject it because it will lock the DAG node and figure out if required links are in there and the right content types for the data. And then your second question, no, that sounds awesome though. I didn't know about that.
We should talk about it.
Yeah, that'd be sweet, because right now it's just, I mean, I guess I kind of just like, it's fairly analogous to the transloaded service, in the sense that like it'll, you know, it walks through stepwise and figures out what needs to happen. But yeah, I mean, so we currently only have like a way to resize images and extract exit from it, but it's pluggable. Like you could, if you wanted to figure out how to handle like PDFs, or we definitely want to do videos soon, or audio or whatever. So yeah, it'd be a great time to get like a real spec.
Cool.
Excellent. Thank you. Next question goes to David.
I actually have a bunch, so I'm having a hard time like picking one, like the one that I'll ask. I guess I'll just like follow up after by email with more. So yeah, like this is like amazing work, and I'm in full support of creating the Firebase or something like for the web. I totally agree with that proposal, and I know that the Dynamic Data Working Group is also working on something similar. I'm wondering if you are familiar with the work that they are doing there, and how much of this is like custom to Textile's use case, and how much like does it map to PeerStar app and PeerStar and so on? If you are familiar with that work.
Hmm.
Well, so last week I talked with Pedro and Jeremy, and we're definitely like I really want to not build like a castle in the sky custom thing. So very much interested in collaboration and you know, if there's built-in core stuff that emerges from dynamic data, I'd love to just use that instead of what we have. And yeah, so that definitely open there. And then what was your second question? Sorry.
Yeah, I'm curious to understand like if there are some specific design decisions of like the textile format that
Right,
do not match to the things that like dynamic data working group has been working on.
Right. Well, so yeah, like Pure Star. And so our we have these profiles that's really just super basic. Like we don't. If someone had a really nice identity solution or something like that, it would we would hope to just plug that in. Like we don't really want to be in the business of creating yet another solution there, or something that it requires you to be in textile. So it would be awesome to be able to, you know, enter the textile into that space with, you know, an existing ID or even like a centralized ID to bootstrap your account or something like that.
Okay, we are going to take one more question from Jim.
Okay, just quickly, you guys have really done great work trying to get this on iOS and Android, and that seems like an incredible engineering effort. I'm very curious about what limits you've seen with performance and power consumption and sync performance and things we can help out with.
So honestly, we haven't done like a really rigorous analysis there. I can tell you it's not great. It's definitely, it is a power hog. And it's actually one of the trickiest things we had to deal with is starting and stopping the node and all that handling around when it comes online, the various things that you can do now when you're online versus the various things you can do when it's just in a started state where you can like add data to your local node and stuff like that, but you can't, for example, use any of the libp2p services. So that's at this point it would be, I feel like it's going to be cumbersome for just someone to pick it up and start building with. We really want to improve that experience, but yeah, things like that are really hard to deal with. But yeah, I wish I had better or any numbers around like power consumption. We just kind of like just hope the phones get more powerful.
Well, Sander, thank you very much for giving your time and talking about textile.
Oh yeah, thanks for the interest.
Yeah, thank you very much. We will be following the developments of textile photos, and yeah, if you need any help from us, you're part. You can always ping us. We can always ping you. Thank you, everyone. I would like to also thank Alan for taking notes, and I'll see everyone next week. Have a great week. Take care. Bye.
Oh, David, I am going to be meeting with Pedro later this week if you're interested.
Can I get like an invite to that event? Like to
yeah.